Hello everyone again to my YouTube channel. Today in this session, I will share with you some frequent questions in statistics. So because as we know, statistics is important in data science and in data analysis, and also for forecasting and for prediction, because the algorithms work with statistics. Well, I will show you some in this part because I will divide this theory of statistics with this form of questions, and I try to give you answers about that. Well, if you're looking with me in this notebook, I have the question number one. What is the difference between inferential statistics and descriptive statistics? Well, descriptive statistics provide exact and accurate information. So if we look in this answer for descriptive statistics, it's provide exact and accurate information. Why? Because we're working in simples. Simples does mean if we look in the population of something, we try to using or choose sample from this population. At this time, we try to describe these measures of the samples and get information based on the sample we have. Well, here I will give you an example about that. So using this package in Python, I use in Seaborn because Seaborn we have a functions called load dataset, and we have also some datasets just for paper education. I use one of them is dataset we have. I import Seaborn. Okay, I create a variable called data equal to is ns.load dataset. I give it other data arrays. Okay, arrays dataset is famous one also. I call just for five top records here. As we see, we have petal length, petal weighted. Sorry, we have sepal length, sepal weighted, petal length, petal weighted, and we have spaces. So if we look in this kind of problem, it's a multi-classification problem because based on this measurement we have five features. We try to predict which one of these simple is species is. Okay, we have because we have three types of these flowers iris. Well, what is important on that? It's to give you an overview. Okay, sorry, I will add in now. Here just to show you. We have data. Okay, sorry, not describe. Run it. We show you now what is the descriptive statistics. So as we look here, because all the features here is numerical one. As we know, the statistics we working just with numerical variables. So if you look in here, we have we taking this first feature here is bit length. We see the count, the numbers of records or rows we have. We have also the mean. We have standard deviation. We have minimum. We have 25%. We have 50%. I mean median. We have 75%. We have max value. So for each of these four features we have here, that's what's called descriptive statistics. Because we described the statistic of this simple because here is just a simple 115 is just a simple here famous statistic. Okay, this information is provided exact. Okay, it's exact and provided because we working in simple. So if we look in the second part, which is question, I mean inferential statistics. So if we look in this definition, provided information. So inferential statistics provide information of simple, and we need to inferential statistics to research to a conclusion about the population. Well, uh, here in inferential statistics does mean we try to draw conclusions from simples because it's not possible to collect all the data for a population. So if we give you example of weights of all human exists in the world does not possible. Why? Because we have over than 7 billion people, so it's not possible to measure all the weights of each one in the world. So for this reason, we taking just samples. We can take in samples, and we have also some techniques to use that. Can one of the famous techniques to trace samples, it's a random choice. I mean, I choosing just some elements for my sample randomly, so without any strategy. And we have also other methods. Well, the idea behind this informational statistics, I mean, we try to draw conclusions from samples and generalize it to population. We try to understand the population just with samples or from samples. Okay, we can choose into samples, tree that's different. Try to analyze it all. At this time, we cannot draw conclusions to this population. So let's see the second question here. Okay. Second question, what is the difference between population and sample in informational statistics? From the population, we take in a sample, as I tell you before. We have the population, that means population, we take in sample. So we cannot work on the population either due to computational cost or due availability of all data point for population. That's as I tell you before. It's not possible to work on all the population we have. That is very cost, and we have problem. So as I told you before, we have two triggers. The first one is the cost, and the second one is availability of other point for the population. There is no way to provide all information for our data. So from simple, we calculate the statistics. Just if we choose in just random simple, at this time we can have the ability to calculate all the measures of our sample. Overall, from simple statistics, we can conclude both population. That means, based on the sample provided, we can draw conclusions for our population. So when we analyzing some phenomena or like something like that, before, so I can, I will record some tutorials about this technically. We show you with Python how we can do that. I will try to solve some problems with informational statistics, okay, using Python, but not now. But I will do that in the future sessions. Well. So if we continue in this area, we can also see or some basic concept in statistics. It's very important, fundamentals of statistics. So we have the first one is center. Center, that means middle of data. So when we're talking about center in statistics, that means the middle of data. We have a data and we have the center of this data. So we have mean, median, and mode are the most commonly used as a measure. So we have mean, median, and mode. 3M. Okay, we can call it 3M. It's most useful in as a measures. So if we go to mean average of all the numbers. So we were talking about mean. That means if we have a range of a list between brackets of numbers at this time, if we can see the mean, we just sum all the elements divided by length or the number of elements we have. Sum of elements, okay, sum of numbers, sum of measures divided by number of elements we have. Why? Well, sorry, it's for me one disadvantage of this mean it's sensitive to outlier because statistics we cannot separate it from because we discuss these statistics in a point of view of machine learning and data science. Well, why these measures is important? Because in machine learning and data science in general, we were working in some projects. We're gonna facing empty or non-value. At this time, we need to build in our strategy to handle all this missing value. To handle that, we're using the mean or median or mode. Disadvantage of mean is sensitive to outlier. I will show you what is the outlier. Outlier simply some values is out range of data we have. So we cannot find some outliers in the left or in the right, and we have some techniques to discover that. We have also median, the number of or the number in the middle. I mean, if you have a list of values, the middle of this list is called median, and median is favorite one because not sensitive to outlier. Okay, and we have the third one is mode. Mode number of occur of the most. And disadvantage of using mode is that it's It's there may be more than one model or one mode. Sorry. Well, the mode is the most frequent value. If we look in the distribution, we have the peak of this curve. If we look in the top of this curve, we have most frequent values. At this time, that's what's called the mode. But one of the disadvantage of this mode that means kind of facing more than one mode. That means kind of finding two, three peak. That means we have three frequent values. At this time, which one we gonna treat it to replace it or to replace the non-value we have. So for this reason, we in the most of time we're using median. Okay, this is the three measures we have, and also we have the concept of spread because we need to see how the data is spread, how it is the dispersion of data in my plan or in my visualization. And we can say that we're using scale or something like that. We can see some thoughts in a plan. So we need to measure this variability we have. Spread, how the data is dispersed. We have range, we have AKR, okay, we have standard deviation, and we have variance. These four measures or four concepts are the most useful as a measure. So for range, to calculate or to see the range is the maximum minus minimum. That means we try to subtract maximum from minimum or try to subtract a minimum from maximum to see this range how it is. We have also EKR or interquartile range. Interquartile range we use in two quarter three and quarter one. Quarter three that means 75% of data minus 25% of data. And at this time we're gonna have something called interquarter. And we have also standard deviation as we see here in this formula. Standard deviation, so we sign it with this or we use to represent the standard deviation this symbol, Greek symbol here, equal to a root of sum of all elements x minus mu x the average, okay, squared divided by n, the mean number of elements we have, okay, and for variance is equal to standard deviation squared. Okay, this is the measures in our data. So, okay, I hope that's clear for you. It's very clear. Okay, it's not complex. Well, we have also shape. Shape is very important. So shape of data can be symmetric or skewed. Okay, sorry for the shape. Perfect between brackets shape we can have is what's called normal distribution or Gaussian distribution. Gaussian distribution. We'll see that after. Okay, we can go behind the questions and see that how it's work and why we're choosing that. Well, just to explain you more and make you in a big picture, this shape is very important because we show for us how the data is distributed. So if we have a curve like that, at this time is normal distribution is it in the most of time to transform all variables or features we have to this symmetric shape. And also we have skewed. For skewed, we have two kind of facing skewed right or skewed left. I mean, center of data is in the left or in the right. The shape is totally different. We can see that the tails in the left is big than a right. In case of a right, but the left one is also tail than a right. That means center of data is in the left. So I give you some example based on this iris data, but it's not clear. But this is how we call this, the shape of data, how it is. So most of the time we see these bins how it is. I mean the number of data is most frequent in our data, but this curve is represent for us this I'm not is semi-symmetric. Okay, it's like symmetric here because we have the data, but we look in here in the right we have this part is still than the left one. Okay, also for this is here is for simple length. Okay, here also for what for simple width. We see that how it is. We have here one mode. Okay, the peak of this curve here. That means we have most of frequent value is here in this. area, and we have here is log normal distributed. Okay, this curve, I mean, this is what you call sheep. It's a very important one. Also for type 1, we have here two peak. That means two mode. Here we have 1 and 2. In this case, it's very hard really to, if we have, or if we're facing some kind of non-value here in this variable of bit length, it's very hard really to use in this mode. So, because we have two modes here, two most frequent values. And type 1 here is not clear. Very, so it's not clear. We have this shape. I don't know how we can describe it, but this curve like flat. So, it's so not clear. Okay, this is what we call shape. We have symmetric before, as I tell you before. The part of light, the part of left is like the right. That's what's called symmetric curve or symmetric distribution or symmetric shape. Well, symmetric, the part of this distribution that is on the left side is the median is same as the part of distribution that is on the right side of the median. As I tell you before, for symmetric one, we have this curve like that. At this time, the same part we have in both, inside left and the right. So for left squid, the left side is longer than the right side. As I told you before, if you have the data, it's go to in the left side. I mean the data or the center of data is exist on the left. And the tail of this curve is more than, in the left is more than right. We have also for right skewed, we have right tail is longer than the left side. I mean, it's inverse of left. The tail of the right, it's more than left. Also, we have concept, it's outlier, the day before that's an important one. In most of cases, we face outliers. I mean, we have some values out of range if you have. So outlier is abnormal value. Keep the outlier based on judgment, remove the outlier based on judgment. How that? If we build in a project in the science and we try to analyze features and variables we have, if we check in the values we have inside of this feature, at this time facing some outlier value, if we try to keep these outlier values we have here in this feature, at this time we need to give a judgment. So for this reason, domain knowledge is very important. Why? Because some values, as I don't know, any area in industry or any area, we should know those variables and the values we can keep in these variables. Okay, if I keep or if I keep the outliers in some feature or some variable, I need to justify why. Also, the same thing if I remove it. But most time, in most of time for machine learning, we try to predict or forecast some values. Algorithms we use is sensitive to outliers. Okay, the most of variables, issue both right rules, that's depend of kind, problem facing, classification, uh, or regression. That's depend of course of kind problem face. So let's go now to fourth question. So for the fifth question, what is quantitative and qualitative data? Where where as we know we have two kinds of two types of data. Quantitative data is also known as numeric data. For qualitative data, it's also known as a category data. So I give you now here an example based on this average data set we have. I tracing this simple length. As we see here, we have float numbers. I mean, it's numeric. So quantitative data. Okay, so quantitative data. And also I tracing here the target one species. I mean, in this arrays, it's also the categorical one. That means qualitative data. Okay, and that's what we see. We have also questions here. Fifth question: how to calculate the range and interquartile range, because that is important for outliers to detect outlier. We have interquartile is equal to quarter 3 minus quarter 1, where quarter 3 is the third quarter, that means 70% present, 70%, 75% of data, and for Q1 is first quarter, 25% currently. Well, as we see here, we have this one. We're just choosing this simple length. We have count the number of simples we have. We have mean also here. We see standard deviation. We have mean and we have 50%. Okay, so this is 25% data. We have 75% data. So to calculate the other quarter, what we do, we based on this example I give to you, we have 6.4 minus 5.1. This is at the quarter. Uh, I have other one here, question, five question. Why we need five number summary? Five number summary, I mean with it, no extreme. We have median, we have upper quarter, and we have extreme or maximum. Uh, if we look on this visualization here, it's on the old example I give you. I mean the race. It raises the hospital weights. Here, this is a box plot. We have here, this is the minimum. Okay, we have quarter one here in this area. We have median here with this line, straight line we have here in the middle. It's not in the middle exactly, but it's in the box, in this blue box as a background. And we have here 70% portal, and here we have maximum. If some dots show it here or here to the right on this side of this box, that's what's called outlier. I showed that before, some examples, some projects I worked before. We have some dots point here, can be got some dots here in this left or the right out of this box. Box plot, that's what's called the outlier. That means some value is abnormal. Okay, so I hope that's clear for you. I want to make this tutorial more short just to focus and explain more. I will see you in the next tutorial about the same topics with new questions. I hope you learn more and happy learning for anyone again. See you again. Bye bye.